Good morning, students. Today is Tuesday, April 28th. This is your science lesson video, and it's our last lesson video related to the outer planets. Well, in fact, to all the planets. So where we have gone before is we have focused on the solar system and how the planets rotate and revolve. We've talked about orbits and moons and how light is involved in cycles like the seasons and eclipses and the moon phases. And then we started learning about the planets, and our standard we're focusing on is that we can analyze the composition and the different planets based on their composition, their features, their moons, their orbit, their rotation. And we're going to do a Kahoot like we did for the other one, so we can practice with our inner and outer planets. And then this is our last lesson, so you have been asked to do a brain pop video and update your chart, and your chart should be looking kind of like this at this point. Remember, this is 100 points for your completed chart. That's how I know that you're watching your brain pop videos. You have your last Pluto video today. You're going to add to your chart, and then we're going to read our last article. So you had a really short 2 to 3 paragraph article to read every day, and a comprehension question to go with it to practice our writing and our comprehension skills. And we're going to read Peculiar Pluto. You can either go on readworks.org and listen to the video. You can read using the pictures that I put on the canvas, or you can also just watch the video and close read with me. And we're going to answer our annotated note and question. We'll check in tomorrow on Zoom, and we'll go over our chart, and I'll have a PowerPoint that'll help you with that. I'm going to post your planets Edulastic tomorrow, and then we're going to start our diagram, and this is going to be kind of an art integration because I know you guys really like art. All right, so I'm going to look in my packet, and I'm going to find where it says my date. So on Tuesday, April 28th, Brain Pop, Peculiar Pluto. Our question that's going to guide us is, how can you compare and contrast Pluto to the planets? So remember, Pluto is actually a dwarf planet, and we're going to talk a little bit about what makes a dwarf planet a dwarf planet. We're going to look at our pre-reading skills, looking at our text features. We're going to highlight and underline and rewrite by putting ideas in the margin, circling key information, maybe making a note if we have a question. That's how I'm going to know that you read the text. I need to see that your text is marked up, and then we're going to complete our reading assessment. And this is your exit ticket. So it's text features on page 39. Provide the reader with key information about how Pluto is different from the other planets. Explain, there's a typo there, the importance of each diagram and illustrating this difference. And our skill we've been really working on for our planets is I can analyze the author's use of text features. All right, so we're going to go ahead and find our story, which is Peculiar Pluto. It is 1, 2, 3 paragraphs, plus these really cool diagrams, and that's what your question is on. And then 4, 5 paragraphs, 6, 7, 8. So this is the longest story that you've had to read. All right, Peculiar Pluto. So I want you to pause. If you haven't already read your article, read your article and mark your text features. What are the names of the features and what information do they give you? So go ahead and pause your video now. All right, so I'm assuming that you've marked your text features. We're going to go through. This should be real quick at this point. A title, peculiar. That tells me there's something strange about Pluto. This text is from a NASA space place. You could Google NASA. I put that as one of your extra links on there. It has some great stuff. Which sentence best describes Pluto? This is a subtitle. They're using questioning as an author to help us get engaged. Then we have a photo of Pluto. We have a caption. NASA Johns Hopkins University Applied Physics Laboratory, Southwest Research Institute. one of the final images taken before New Horizons made its closest approach to Pluto on the 14th of July, 2015. Down at the bottom, we have, you could either call this an illustration or a cartoon. There's no things labeled, so we wouldn't call it a diagram. And we have a little planet with a crown, and then we have another little planet. I'm not sure what those are, planets or moons, or we'll have to see. Then we have a map, and it says NASA, it says Pluto and Charon, and it has the United States. So I'm seeing that Pluto is about the same size as the United States. And this is more fun facts about Pluto. That's a subtitle. Then we have our two diagrams. Both of our diagrams have captions and titles. So I see Jupiter, Saturn, Uranus, Neptune, and Pluto. And then this is a bigger image because it's so small you can see it. Here are your inner planets: Mercury, Venus, Earth, and Mars. And I'm noticing that all the planets have pretty similar orbital paths, but then I'm noticing that Pluto has kind of a weird orbit, that it actually overlaps with Neptune, and then it goes really far away over here. And this says view of looking down above the sun. And we have our caption. In the picture above, the arrows show the direction of the planets and Pluto rotating. Notice Pluto's spin goes the opposite direction of all the others except Venus and Uranus. So most of the planets spin counterclockwise, but Venus, Uranus, and Pluto spin or rotate in opposite direction. That's what our arrows are showing. Then we have the view looking from the edge of the solar system. So this is the same image, but from the side. And I see here's my enlargement. And I'm noticing that all the orbital paths are kind of flat, except for Pluto has a tilted orbit. It's definitely not the same as the other planets. And then we have a caption. In the picture above, the arrows show the direction of the planet and Pluto's axes of rotation point. Notice Pluto's and Uranus point along the same plane as their orbits instead of more or less up and down. So if you look at their orbit, it's tilted. Alright, we're going to go to our next page. We have another diagram. And it says Pluto, and it shows its orbit, and Charon, which must be its moon. And here's Pluto's orbit, and here's Charon's orbit. So whereas we have the Earth and the moon going flat, Charon spins this way, or rotates and revolves that way. If you lived on Pluto, you'd live to be 248 Earth years. And this would be another cartoon or an illustration. Alright. And then our last one, I see an elephant, and he's on a scale. This is an illustration. And I'm thinking about what I know about gravity, and how gravity is bigger on a larger amount of gravity on larger planets. But I'm thinking something must be weird about Pluto, because they said peculiar Pluto. And then we have a subtitle. Let's go there. Alright, so I'm going to start close reading. Remember, when I pause, the expectation is you read the next word. We're going to get our highlighter out to highlight. What genre are we looking at? Nonfiction. We also call this expository. meaning it's real. So we're going to look at things like who, what, when, where, why, and how, and we're going to highlight our key ideas. Pluto is actually closer to the sun than Neptune for about 8% of its orbit. Ooh, closer to the sun than Neptune. So remember how the orbit changed. It runs into or crosses Neptune's orbit. Pluto is just one of many icy objects in a distant area of the solar system. What is it? It's an icy object. Pluto and its large orbiting companion object, Charon, are tipped on their sides. So it's not really a moon. They're calling it a companion or friend, and they're tipped. And the answer to this question is all the above. All right. Well, you just pick the answer you like because they are all. Pluto is that lies in the Kuiper Belt, is an area full of icy and other dwarf at the edge of our solar. Because Pluto is the biggest object in this, some call it the king of the Kuiper Belt. One thing is certain, Pluto and its if scientists could unravel some of their, we would know more about how our solar system. All right, so we're going to pick, what is it? It's a dwarf planet. Where is it? In the Kuiper Belt. How is it, what is it made of? It's an icy body. Where is it? At the edge of our local solar system. And what is it called? The king of the Kuiper Belt. Pluto is only about half the width of the Charon is about half the size of. Charon is the largest moon compared to the body it orbits, whether planet or dwarf planet, of any moon in our solar. So Charon is the largest moon out there compared to what it orbits. So Charon, the moon, is almost as big as the dwarf planet. Almost all the planets travel around in nearly perfect, but Pluto does not. It takes an oval shape with the sun somewhere near its. What's more, its path is quite tilted from the nice orderly plane where all the other planets orbit. Mercury has a slightly lopsided orbit too, although not nearly so much as Pluto's. All right, so Pluto does not. It has what is it? It has an oval-shaped path around the sun, and its path is tilted. All right, and so we already looked. So instead of it being a perfect circle, it crosses the path here, and it goes really far here. And then instead of it being flat and a plane around the sun like all the other planets, it's tilted. Compared to most of the planets and their moons, the whole Pluto-Charon system is tipped on its, like the Pluto's spin axis stays pointed in the same direction as the sun, as it orbits the sun, but unlike all the planets except Pluto is tipped on its. The planet's axis of rotation stay more or less upright from the plane of their orbits. All right, so the Pluto-Charon system is tipped on its side. And this is just like Uranus. If you lived on Pluto, you'd have to live 248 Earth years to celebrate your first birthday in Pluto years. So one Pluto year is 248 Earth years. You'd be very, very old. And remember, these are revolutions. 1 year. So a year in Pluto years is 248 Earth years. All right, I'm going to pause our video here. I'm going to pick it right back up in our second video, and we'll go over our ERQ question.